Yeah, so I've been given 10 minutes. I'll try to make it in 5. Just 2, 3 key concepts quickly. I think we all know a lot about ventilation. We've been talking about ventilation and the standards as they call for increased amount of fresh air. So when you bring in fresh air, you have a challenge, you increase your load, you increase your energy requirements. Do you really want to do that? You want to balance it. And that's the designer's dilemma, so as to say. So we manufacture wheels, so I'm going to speak about wheels, mostly about wheels, and how we can apply them, and the new technology, like the certification programs. So when you talk about wheels, there has been a fair amount of understanding about it. If you look at this hotel, in 2013, they installed energy recovery wheels. And what they gained was absolutely amazing. They could significantly reduce the total impact of ventilation. They could actually bring down their energy costs, and fresh air induction was happening at the desired levels. So I think wheels have been playing a great part in the GCC. And in many countries in the GCC, the adoption has been very encouraging. So for suppliers like us, that's pretty encouraging. If you look at the next paradigm shift, I want to draw your attention to the next paradigm shift that is happening for the last 5 years. Especially started in some of the hot and humid climates, and now in GCC, the adoption rate is pretty high. Let's quickly talk about RH control. We spoke about energy recovery. You know, my previous speakers spoke about energy savings, efficiency, decarbonization, pretty amazing topics. But when you really look at energy efficiency and RH management, there's a very close correlation. Our experience in hot and humid climates has taught us that we can actually divide the load. We can divide and conquer. You can separate the sensible and the latent load. You can do a kind of a dual wheel system. So as I said, I'm a wheel manufacturer, I talk about wheels. The OEMs do the integration, they manufacture these units, and they are prevailing a lot across the GCC. The traditional approach was use an energy recovery wheel with a cooling coil and then use a reheat coil, and then get the air into the duct. And from the supply, nothing was being recovered from the exhaust. So now the new approach is to use a sensible wheel. So when you use a sensible wheel, what do? You remove the reheat requirement, the reheat coil is gone, and you're also sort of preconditioning it quite well. You're also recovering something from the room return, as well as you're bringing down the overall tonnage and load. So sensible wheel adoption in a dual wheel strategy has been kind of a growingly important paradigm shift in the GCC. The second dimension to this is also evolving, and this one, especially in the last 3 years. And since this forum is about new technologies, I think, so this is the technical part, what I just said. If you look on the psychometric chart, you are pre-cooling and dehumidifying, then you're supercooling, and then you are reheating it again without a reheat coil. And simultaneously what you're doing is pre-cooling it again from the return side. Now I introduced you to the passive wheel concept. Now if you look at a passive wheel, a passive desiccant wheel, so we've been using desiccant wheels for a long time in food, pharmaceuticals, lithium-ion battery manufacturing, and so on. There are so many good examples in the GCC. But if you look at a kind of an application with a dual wheel, where instead of the second wheel being a sensible wheel, you take it as a passive desiccant wheel. What do? You actually bring down the dehumidification requirement, because your passive desiccant wheel is doing your dehumidification. What does it mean? Lower dew point. What does it mean? It means a lower load on your cooling coil. So your cooling coil load can totally reduce by using a passive desiccant wheel in conjunction with a energy recovery wheel. So this dual wheel system is gaining a lot of adoption, especially in humid climates. Now, if you see the table, I'm sorry, the data is pretty small over there, but that's about Jeddah. We've done research in Jeddah, we've done research in Dammam, and it's very encouraging. It's extremely encouraging to see the kind of results we get. This is a table. I don't want to bore you with numbers, but if you just look at two tables, two columns, one is the cost of the load and the cooling load and the savings. I think it's pretty amazing. If you look at a double wheel system, the savings in terms of your overall power requirement, your electric power, your cooling coil load, it all goes down considerably. And at this forum, where we are talking about energy recovery, decarbonization, saving the planet, it's absolutely important and most mandatory. The last 1 minute I'll need is on an emerging new technology of indirect direct evaporative cooling. The previous speaker spoke how more than 50% of the greenhouse gas emissions are owing to commercial refrigeration. Now, what if you could reduce a little bit of that load? What if you could sort of look at warehouses, open spaces, open area cooling, probably pre-cooling for an AHU, for a large building, and sort of pre-cool it without using any refrigerant. That's indirect direct evaporative cooling for you. There's a special module. It's a polymer module. And it's not new in the kingdom. It's been there for like 5 years. And the adoption is only gaining. If you look at the results, those were done for Riyadh. And they are pretty amazing. If you look at the psychometric, you're actually not injecting moisture. You are cooling it adiabatically. And you're also ensuring that it stays within the comfort zone and the comfort level. So on an overall FAHU comparison, we are not talking about replacing FAHUs. That's totally different. We are only talking of supporting the paradigm. We are talking about reducing your load. We are talking about ensuring adoption of greener and cleaner technologies to meet your decarbonization goals with lowered costs. So indirect direct evaporative cooling is an emerging technology in the GCC. And looking at the conditions and the results we get here, it's very encouraging. So that's all. Thank you.